Hello student, today we are going to start the chapter number 12, that is the magnetism. Just 1 minute. That is the magnetism. What is this magnetism? Up to this, we know that the magnetism is nothing but that is the property of the substance which attract the small pieces of the iron. This is magnetism. Important terms. Video कुणाचा आवाज येतोय स्टुडंट प्लीज म्यूट युअर सेल्फ. Yes. See the important terms and definition. First upon, what is meant by magnetism? Magnetism is nothing but the property of the substance attracting small pieces of iron called magnetism. And the word magnetism is oriented from the iron that is called magnetite. And from this word, that is the magnetism. And the natural magnetism or the natural magnet is called as the lodestone. Okay. This is the basic of this magnetism. Magnetism is nothing but the property of attracting small pieces of iron called magnetism. There are some types of magnets. First one is the natural magnets, and then that is the magnetic dipole. The stones which possess the property to attract other stones are called as the lodestones. And where these lodestones are suspended freely and it remained in equilibrium in north-south direction. This is very important property of the magnet. That means when we suspend it freely, each and every time and at any places it show or remain in equilibrium in north-south direction. Then magnetic dipole, an arrangement of two magnetic poles of equal and opposite strength, like is an electric dipole. We have learned this electric dipole. Electric dipole, that is the two equal in magnitude but opposite in charge. These are separated by a finite distance. This is called as the electric dipole. Similarly, the magnetic dipole. Just 1 minute. Mute yourself. Magnetic dipole, an arrangement here in case of the magnetism, that is the arrangement of two magnetic poles of equal and opposite strength separated by a finite distance is called as the magnetic dipole or a bar magnet. And the two magnetic poles of dipole are called N pole and S pole. Here these two poles, that is the in case of magnetic dipole there are two poles. जसं आपण पॉझिटिव्ह आणि निगेटिव्ह चार्ज, जसे in this case there is a N pole and S pole. An isolated pole does not exist. That means there is no self-existence of N pole or S pole. When you obtain this magnet, each and every time, maybe very small piece of this magnet, it's having N pole and S pole both simultaneously. There is no existence of only N pole and only S pole. This is the very important characteristics of this. Now, some commonly known facts about the magnetism. This is your basic knowledge. Every magnet, regardless of its size and shape, has two poles called North Pole and South Pole. म्हणजे तो मॅग्नेट कितीही छोटा असला तरी सुद्धा त्याला एन पोल आणि एस पोल असे दोन्ही पोल असतात. Okay, if a magnet is broken into two or more pieces, then each piece behave like an independent magnet. That means if you break the small pieces into small pieces of this iron, that of this magnet, then what happened? This weaker magnetic field, and they are independent magnet with somewhat weaker magnetic field, and thus isolated magnetic monopoles do not exist, and the search for magnetic monopoles is still going on. Like magnetic poles repel each other, whereas unlike poles attract each other. And when a bar magnet, that is the magnetic needle, is suspended freely or pivoted, it's aligned itself in geographically, that is the north-south direction. The next, what is this bar magnet? The north and south, that means sides, represent poles of the bar magnet. When you say bar magnet, what is its meaning? That means it's having north and south side that represent the poles of that magnet, and which is called as the bar magnet. Bar magnets are nothing but these are the examples of permanent magnets. All magnets are polarized, which means they have two distinct and opposite ends. Opposites pole attract while similar poles repulse. This S and N repel each other, and these similar poles repulse each other. Now see, what is this magnetic lines of force? Similarly, like in the case of when we see electric line of force, similarly magnetic line of force and magnetic field, we have studied properties of electric line of force earlier in the chapter, that is in electrostatics. What is these properties? We know that in case of the electric line of force, this started from positive charge and end on the negative charge. I'm just review this. Okay, in similar manner, this magnetic line of force originated from the North Pole and end on the South Pole. And this magnetic line of force, that is have the magnet following properties. The magnetic line of force of magnets or a solenoid form closed loops. This is contrasts to the case of an electric dipole. What happened in electric dipole? In electric dipole, this electric line of force started in case positive and end on negative. But in case of this magnetic dipole, what happened? This started from the N pole and end on the S pole. But inside it again, it is from south to north. That means there is the formation of closed loop. See, here this is started from this, and inside again this is from N to S. In this way, there is the basic difference between the magnetic line of force and the electric line of force. When we're studying this, we are just comparing what is the basic difference between the electric line of force and the magnetic line of force. In case of electric line of force, they started from positive charge and end on the negative charge. In case of the magnet, it started from N pole and end on the South Pole. Next, this direction of the net magnetic field B bar at a point is given by the tangent to the magnetic lines of force. That is the point, the direction of the line of force, and the number of line of force crossing per unit area decide the magnitude of the magnetic field. This is nothing but the definition of your magnetic field, that is the B bar. That is the number of line of force crossing per unit area decide the magnitude of the magnetic field B bar. The magnetic line of force do not intersect, and this is because they had because had they intersected, the direction of magnetic field would not be unique at that point. That means there is a uniqueness of the direction, and so that the magnetic line of force do not intersect. These are some properties of the electric line of, that is the magnetic line of force. Now see in basic, what is this basic equation here? This magnetic bar, that is, this is the magnetic length. When we take the magnetic length from pole to pole, then it is called magnetic length. And when you take from these sides, both sides, then it is called as the geographic length. That is the line joining the poles of the magnet is called magnetic axis. And the distance between the poles of the magnet is called the magnetic length of the magnet. See the distance between the pole of the magnet, where inside this is P and this is point P. These are nothing but this indicate the poles, that is the south pole and north pole, and the distance between them, it is called as the magnetic length. And end to end distance, when we take the end to end distance, then it is called as the geographic length. The distance between the end of the magnet is called the geometrical length of the magnet. That means when we take magnet and measure its length end to end, then it is called as the geographic length. But somewhere inside that magnet or that bare magnet, somewhere from that outside of or inner side of the magnet, that means the end, inner side of the end, there is the presence of N pole and S pole. And when we take that distance, then it is called as the magnetic length. And the ratio of magnetic length and the geometric length is nearly 0.84. This is your information. Okay. Now, what is this magnetic dipole and dipole moment? Up to this, you know that what is this magnetic dipole? Magnetic dipole is nothing but a pair of magnetic poles of equal and opposite strength separated by a finite distance. It's called magnetic dipole. And the magnitude of dipole moment is the product of the pole strength. Suppose pole strength of N or S, maybe it's M, and the distance them is 2L. Then it is given by, that is the dipole moment is capital M bar is equal to M into 2L, where the SI unit of the pole strength is ampere meter. And what is this magnetic dipole moment here? Capital M is equal to M into, what is this M? M is nothing but the pole strength. And what is this 2L? The distance between that two magnet. Just 1 minute. The direction of the dipole moment is from south pole to north pole and along the axis of the magnet. See the direction of the dipole moment directions are. This direction is from dipole moment south to north pole along the axis of the magnet. Once again, see this definition because this is very important definition. First one is the magnetic dipole and second one is the dipole moment. What is this magnetic dipole? A pair of magnetic poles. We know when the magnet is made up, it's having the north pole and south pole. These two are separated by a finite distance. That means pair of magnetic poles of equal and opposite strength separated by a finite distance is called a magnetic dipole. And the distance between them is near about taken 2L. And the individual strength of each pole is taken as small m here, pole strength. And so the magnetic dipole moment as per the definition is equal to capital M bar is equal to small m, that is the strength, and the 2L, that is the distance. Okay, and the pole strength having the unit ampere meter. Obviously, this having the ampere meter square, that is the magnetic dipole moment SI unit ampere meter square. The next, what is the density of line of these lines? That means this number of lines force, that means line of force per unit area. That is the density of lines of force. Here the number of lines of force per unit area normal to the surface around a particular, that means around a particular area. See in your book, this is also given when the point determine the strength of the magnetic field. Here I separated the definition here. That means the number of line of force, that means passing through that area, this number of line of force, that is nothing but the magnetic flux. SI unit of magnetic flux, phi, that is the Weber, its unit Weber. SI unit of magnetic flux, phi, which is indicated by the symbol phi, and its unit Weber. For a specific case of uniform magnetic field, which is normal to the finite area A, the magnitude of magnetic field strength, that is the B, that means the magnetic field is given as magnetic line of force, that means magnetic flux. Once again, see this definition. This is important definition. How you can define the magnetic field? Magnetic field is nothing but the magnetic line of force per unit area. And we know that magnetic line of force is called as the magnetic flux per unit area. So magnetic flux, which is given by the symbol phi, per unit area, that is the area is here A. So B is equal to phi divided by A. The SI unit of magnetic field B is expressed as Weber per meter square or Tesla. See, Weber, that is the unit of this phi, and A, area, unit area unit काय आहे meter square. So the SI unit of magnetic field is equal to Weber per meter square. Also, it is called as the Tesla. 1 Tesla is equal to 10 raised to 4 Gauss. Once again, see how we define here this magnetic field. As per the definition of the magnetic field is nothing but the magnetic line of force per unit area. Magnetic line of force, that is the magnetic flux per unit area. Here we take area, suppose A. So phi divided by A is nothing but the magnetic field. Next year, see, the density of field lines indicates the strength of the field. With the help of this diagram here, the density of field, see, this is the N pole, this is the S pole, and this weak magnetic field here, and here this, that means these lines are widely distributed. And when these lines, that means this magnetic line of force, when these are widely distributed at that area, the weak field, that means at that area the magnetic field is weak, and when they are separated or gathered at that surface or at that area, the magnetic field is strong. Here in your book on page number, see, the page number is given on the in your book, page number 223. There is the, that means the given the difference between the electrostatics and magnetism. That is the basic physical quantity. In case of the electrostatics, here the electrostatic charge. We know that electrostatic charge are the charge that are not moving. And in case of the magnetism, the physical quantity are magnetic poles, that N pole, S pole. Here the charge, positive charge, negative charge. Here the field, in case of electrostatic, there is the field electric field. In case of magnetism, this is the magnetic field. Here the constant in case of the electrostatics, the constant 1 upon 4 pi epsilon naught. In case of magnetism, we are going to take the constant mu naught divided by 4 pi. Again, in electrostatics, we have learned the dipole moment is given by P bar is equal to, that means the symbol of dipole moment is P bar. Here the symbol of this dipole moment M bar. M represent magnetism. Here this P bar dipole moment of this, that means in case of electrostatics, Q into, that is the charge of this charge, and then distance. Here this pole strength and distance between the two. Here along negative to positive charge, and here from S pole to N pole. That means here are the two charges, positive charge and negative charge. And in case of magnetism, south pole and north pole. Again, force is given. In case of this electrostatics, F is equal to Q into E bar. Here, instead of this E bar, here the field is magnetic field. So P bar. And so QM. Energy that is in external field of a dipole, which is given by minus P into E bar. Here M into B bar. Again, as per the Coulomb's law, this force is given by 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. We know that the Coulomb's law, the force of attraction or repulsion between the two charges is given by, is directly proportional to the magnitude of the two charges and inversely proportional to the square of the distance between them. This Coulomb's law is not applicable to the magnetism because it is no analogous law, as magnetic monopoles do not exist. Here, in case of electrostatics, there is the existence of positive and negative charge individual. Maybe positive charge present, it is not necessary, there should be a negative charge. But in case of magnetism, when there is the presence of south pole, obviously there is the presence of north pole. Again, the axial field. In case of this axial field, this is given by 2p divided by 4 pi epsilon naught r cube. Just 1 minute. Hello student, तुम्हाला स्क्रीन दिसत नाहीये का? Hello, give me answer please. Hello.
हो मॅम.
Yes, ma'am. Yes, ma'am.
तुमच्या समोर स्क्रीन दिसत नाहीये का?
नाही दिसत आहे.
एक मिनिट एक मिनिट मी बघते, 1-2 मिनिटं थांबा. Hello student. स्क्रीन तुम्हाला अजिबातच दिसत नाहीये का? यस साकोर, ओम.
नाही दिसत आहे मिस.
ठीक आहे, 2 मिनिट. टेक्निशियन येत आहेत, मी परत पहिल्यापासून सगळ्या स्लाइड दाखवते आणि परत एक्सप्लेन करते, डोंट वरी. 1-2 मिनिटं थांबा. थांबा 1 मिनिट, तू थांब, इथे जाऊ नकोस. हा, दिसतंय का स्टुडंट? हॅलो,
हो
Yes,
मिस
ma'am.
दिसतीये.
Yes.
आता दिसते का?
हो.
ओके. मी परत पहिल्यापासून एक्सप्लेन करते, परत सांगते सगळं थोडक्यात. हा, सी, आता दिसतंय? ओके.
Yes,
एकाने
ma'am.
सांगा म्हणजे
Yes,
मला
ma'am.
कळेल. ओके, जसं आपण वर्गात आहोत तसं समजा. आता
मॅम परत गेलं.
थांब 1 मिनिट. आता दिसतंय का?
येस मॅम,
हो.
दिसतंय.
ठीक आहे. ठीक आहे, आता हे असंच राहू देते. ठीक आहे. व्हॉट इज मीन बाय, कोण रे कोण मारतय रेषा? मी आता वर्गात इथे मला नाव समजतंय. हा, कोण आहे? यासाठी आपण लेक्चर कंडक्ट करतोय का? खोड आता तूच. हॅलो, नाव बघायला पाहिजे. सी, तुमच्या बरोबर ना वेळ घालवणं म्हणजे तुम्हाला शिकवायचं की तुमचे हे बघत बसायचं रे? आता स्क्रीन दिसतीये का सगळ्यांना? हॅलो स्टुडंट.
येस मॅम, दिसतंय.
Okay. Now see, what is this bar magnet? Next article, that is the bar magnet 12.3 article in your book. टिक मार्क करायचे. पुस्तक समोर आहे ना? सगळ्यांच्या समोर बुक्स आहे का नाही? अरे हो की नाही?
आहे.
मॅम.
Okay. Bar magnet. What is mean by bar magnet? It is nothing but the magnetic pole strength. Positive Q M. M for magnetism. Just here we indicate this M for, that is the magnetism. This plus Q and minus Q M at the North Pole and South Pole respectively. And see here the separation. The separation of the magnetic poles inside the magnet is 2L. That means the distance between them is nearly, we have taken 2L. As the bar magnet has 2 poles. We know that bar magnet has 2 poles, North Pole and South Pole. It is, that is having the equal and opposite pole strength, and it is called a magnetic dipole. And this is analogous to electric dipole. जसं तुम्ही इलेक्ट्रिक डायपोल मध्ये पॉझिटिव्ह चार्ज आणि निगेटिव्ह चार्ज बघितलं होतं आणि ते सेपरेटेड केलेले आहेत 2L ने. Similarly here, this N pole and S pole having the different pole strength. Different means opposite pole strength, and they are separated by the finite distance which is 2L. And using this, that means this analogy using in case of magnetism, here we define the magnetic dipole moment as M bar is equal to 2. That is this 2L. What is this 2L? That is the distance. And what is this QM? The pole strength of out of them one pole strength. दोघांची pole strength सारखी आहे, फक्त त्यांची मॅग्निट्यूड काय आहे, डायरेक्शन काय आहे वेगळी, एकाची मायनस एकाची प्लस. तर इथे QM into 2L, same as your electric dipole. And see here the pole strength having the unit ampere meter. You have to remember it, this ampere meter, and SI unit of this magnetic dipole moment M is ampere meter square. This is the unit of this both, that is one having the unit ampere meter and another is having the ampere meter square. That means the pole strength unit having ampere meter, only pole strength, and this dipole moment is having the unit that is the ampere meter square. This is very important articles of this chapter. Then what is this axis? Definition. Axis is nothing but what? It is the line passing through both the poles of the bar magnet. Obviously, there is one, just 1 minute, one axis for a given bar magnet. See, this is the equator and this is the axis. What is this axis? This is the line passing through both the poles of magnet. See, this one is axis. ही जी लाईन आहे ह्या दोन्हीही नॉर्थ आणि साऊथ पोल मधनं पास होती, त्याला काय म्हणायचं? The line which is passing through both the poles of bar magnet, which is called as the axis for a given bar magnet. Then next, what is the equator? Equator is nothing but the line which is passing through the center of bar magnet and perpendicular to the axis. See, this line equator, this is the passing through center. Center कुणाचं? बार मॅग्नेटचं सेंटर सपोज O आहे, त्यामधून जाणारी लाईन आणि ती ऍक्सिसला कशी आहे? परपेंडिक्युलर. तिला काय म्हणायचं? इक्वेटर. सो द डेफिनेशन, द लाईन पासिंग थ्रू द सेंटर ऑफ मॅग्नेट and perpendicular to its axis, it is called as the magnetic equator. The plane containing all equators is called as the equatorial plane, and the locus of the points on the equatorial plane which are equidistant from the center of the magnet is called as the equatorial circle. And the popularly known equator in geography, that is actually in geography, equatorial circle. And such a circle with any diameter is an equator. Now the basic remain here only equator. What is meant by equator? Equator is nothing but the line which is passing through the center of the magnet and which is perpendicular to the axis. Then magnetic length. It is the distance between the two poles of magnet. What is this magnetic length? That is the distance between the two poles. And magnetic length 2L is equal to 5/6 into geometric length. हे तुम्हाला MCQ मध्ये विचारलं जाऊ शकतं की what is the relation between this magnetic length and geometric length. Okay, that point 5/6. आता next point आहे तुमच्या बुक्स मध्ये 12.3.1. That is the magnetic field due to a bar magnet at a point along its axis and along its equator. First upon, we are going to see along its axis. Here, in short, each and everything is not in details in the 11th standard. Consider a bar magnet. Bar magnet consider केलाय तुम्ही 2L इतका. That is having the length 2L and magnetic dipole किती आहे त्याची m bar as shown in diagram. Okay, we will now find magnetic field at a point P along the axis. See, this is the point P. Here somewhere we have put this magnet. Okay, when you say magnet word, that means it's having the both S pole and N pole. ज्यावेळेस आपण बार मॅग्नेट ठेवलाय असं म्हणतो म्हणजे आपण एक कम्प्लीट एस पोल आणि एस पोल, कारण कुठलाही मॅग्नेट जर तुम्ही घेतला, अगदी छोट्यातला छोटा जरी तुम्ही मॅग्नेट घेतला तरी सुद्धा त्याला एस पोल आणि एन पोल असतोच. देर इज नो एक्झिस्टन्स ऑफ मोनोपोल. म्हणजे कुठला एखादा मॅग्नेट आहे आणि त्याला फक्त आणि फक्त एस पोल आहे किंवा एन पोल आहे असं होत नाही. ओके, therefore at this point P point ला आपल्याला काय फाइंड आउट करायचं? बिकॉज ऑफ दिस मॅग्नेट, व्हॉट इज द मॅग्नेटिक फील्ड ऍट द पॉइंट P? दिस इज आवर क्वेश्चन. बऱ्याच वेळा तुम्हाला हेच कळत नाहीये की ह्या P ह्या ठिकाणी काय फाइंड आउट करायचंय, की आपण ह्या ठिकाणी हा एक बार मॅग्नेट ठेवलेला आहे, तर ह्या बार मॅग्नेट मुळे P ह्या ठिकाणी किती मॅग्नेटिक फील्ड तयार झालेला आहे, आणि सो that field is give the B axis. That means the magnetic field along the axis, that means the point P is along the axis. See, this point P which is at a distance r from this origin center of the magnet. Each and everything, when you observe this diagram carefully, we can understood what is this R, what is this P. Okay, we now use the electrostatic analogy to obtain the magnetic field due to a bar magnet at a larger distance greater than this. R is greater than L. Consider what is this L? L is nothing but the distance from the center and each pole. Suppose this center is O and each and every pole, that means this both pole here SO, this distance should be L. O and this distance should be L, because this becomes 2L, L plus L, 2L. So this distance R is obviously greater than this L. And so consider the electric field. We are here analogy. Analogy, that means similarity. With the help of the similarity of the electric field, we are going to find out the B axis here. In case of the electrostatics, we have find out that axis here 1/4 pi epsilon naught 2p divided by r cube. But in case of this magnetic field, this B bar axis is given by mu naught divided by 4 pi into 2m divided by r cube. See, this is the equation. Using this analogy here, this is axial magnetic field. What is the axial magnetic field? B axis is equal to mu naught divided by 4 pi into 2m divided by r cube. And similarly, we can find out the point which is at the equator. So, see, this point P is at the equator. So, B equator is equal to mu naught m bar divided by 4 pi r cube. And this is the B equator. Here in your book, this is not necessary to find out this how this B axial come. This is not necessary. So, I skip this here and start the next point, that is the magnetic field due to a bar magnet at an arbitrary point. That means you have seen what is the magnetic induction or the magnetic field at the axis point, and what is the magnetic field at the equatorial point. But when we take this point which is not on the equator and not on the axis, म्हणजे आता आपण असा पॉइंट निवडणार आहोत की जो ऍक्सिस वर पण नाहीये आणि इक्वेटर वरती पण नाहीये, तर त्या ठिकाणी आपलं मॅग्नेटिक फील्ड किती असणार आहे? सो दिस डायग्राम शोज दॅट द बार मॅग्नेट ऑफ अ magnetic moment m bar with center at O. P is any point in its magnetic field, and magnetic moment m bar is resolved about the center of the magnets into components along r bar and perpendicular to r bar. See, in your book, the page number is given 224, that is 224 page, diagram number 12.3. That is the magnetic field at an arbitrary point. What is meant by arbitrary point? The point which is not on the exactly on axis and not exactly on the equatorial. Some random position of that point, and at that point we are going to find out the magnetic field because of the given bar magnet. This is our M. Now here see in this diagram, if you observe each and every diagram carefully in physics, then you can understand the concept of that article. Okay. Also here for component, that is the m sin theta perpendicular to r bar. This is m sin theta. See, this is m sin theta, and this is perpendicular to the r bar. See, this is the r bar. And the point P is an equatorial point at the same distance r bar. Using the results of axial and equatorial field, that means this point is not on the axial and not equator. So we are taking this resultant. This is the axial and equatorial. These are the resultant field here. Therefore, this distance become, that means when you take the B axial, then we have this B axial using the results axial and equatorial fields. First upon equation we got, that is the BA is equal to this BA is equal to mu naught divided by 4 pi into 2m cos theta divided by r cube. And similarly, when you take the equatorial point, at that time you got mu naught divided by 4 pi into m sin theta divided by r cube. Okay, these are the points. When you resolve this, this one is axial and this one is the equatorial for the P point. हे बघा स्टुडंट, तुम्ही जरी इथे पार्टिसिपेंटची संख्या 2-3 जण कमी झाले, परंतु पूर्ण चॅप्टर आज मी इथे एखादंच आर्टिकल राहणार आहे. आणि हा चॅप्टर आपल्या सेकंड युनिट टेस्टला आहे, त्यामुळे तो तुम्हाला नीट अभ्यास करायचा आहे. सेकंड युनिट टेस्टच्या सिलेबस मध्ये टोटल मॅग्नेटिझम चॅप्टर हा तुम्हाला आहे. ओके, त्यामुळे तुम्ही लिव्ह झालात नाही थांबलात तरी सुद्धा लेक्चर हे कंटिन्यू होणार आहे. Thus the magnitude of the resultant magnetic field B at a point P is given by, therefore B is equal to, thus the B is equal to, when you take B square is equal to BA square, but here we want only the B, so under root BA square plus B equator square. And we know the individual values of this BA, what is this? B axis, and B equator, this is B equator. Okay, so putting the values in your book, this is also given. What is the value of BA here? Mu naught divided by 4 pi. These are the constant term, which we take this constant term outside, and so in bracket the remaining thing is, that is under root, that is the 2 cos theta square plus sin theta square. If you solve this, 2 cos theta square, that is the 4 cos square theta plus sin square theta. Those student which is having mathematics, they can understand here. This 4 cos square theta, we can write down 3 cos square theta plus cos square theta. This is nothing but the distribution of this 4 cos square theta, that is 3 cos square theta plus cos square theta plus sin square theta. Here cos square theta plus sin square theta is nothing but 1. And so instead of this cos square theta plus sin square theta, we can write down here 1. So 3 cos square theta plus 1. And so that this equation become B is equal to mu naught divided by 4 pi into M divided by R cube under root 3 cos square theta plus 1. And this is nothing but the magnetic field. This is what? This is the magnetic field at the arbitrary point. Again, when using equation number 1, here we can write down the tan alpha is equal to, with the help of this tan alpha, here this tan alpha is equal to B equator divided by B axial. Therefore, using this here, this mu naught divided by 4 pi, this get cancelled, R cube get cancelled, and this only the value is 1 by 2 sin theta divided by cos theta, which is given by tan theta. And the angle between the directions of B bar and the magnetic this pole strength is given by, that is the theta plus alpha. And this is, here one is theta, okay, this one is theta, and this one is alpha. And so the total angle between this direction B bar is nothing but the theta plus this one is alpha. In this way, here we find out the magnetic field at the arbitrary point. And there are some examples on this, that is, for example, first example, find the magnetic induction at a point at a distance 10 centimeter on the axis of a short bar magnet of a moment 0.2 ampere meter square. That is, this is the dipole moment, 0.2 ampere meter square. Ashe examples, such a type of examples may be in your question paper. Okay, distance from center, that is R is given. See, each and everything is given in the problem. That is the distance 10 centimeter. You have to convert into meter, 0.1 meter. Magnetic moment is given 0.2 ampere meter square. So we know the formula for B axis. B axis is equal to B axis mu naught divided by 4 pi into 2m divided by R cube. Here this distance is, this is the constant mu naught divided by 4 pi, that is the 10 raised to minus 7 into 2 into, that is the m having the value 0.2, therefore 0.1 cube, and solving this we got this equation, that is the B axis is equal to 4 into 10 raised to minus 5 Tesla. In this way, with the help of the formula, we can find out the B axis, B equatorial. These are the examples. And the last articles of this chapter, that is the earth magnetism. What is this earth magnetism? In geography, you have learned that earth is nothing but the big magnet. It is common experience that a bar magnet or a magnetic needle suspended freely in air always aligns itself along geographic NS direction. This is the very important property of the magnetism. If it has a freedom to rotate about horizontal axis, then what happens? It inclines with some angle with the horizontal in vertical, that is the NS pole, north-south plane. And this is the fact clearly indicates that there is some magnetic field present everywhere on the earth. म्हणजे आपण इथे पृथ्वीवरती कुठेही जर आपण चुंबक सूची जर ठेवली तर तुमच्या असं लक्षात येईल की ती नॉर्थ साऊथ डायरेक्शन दाखवते. याचाच अर्थ काय आहे की this is nothing but what? The magnetic field present everywhere on the earth, and this is called terrestrial magnetism, and it is extremely useful during navigation. Magnetic parameters of the earth are described below. Unless and otherwise stated, the direction mentioned south north. These are always geographic. That means geographic तुम्ही डायरेक्शन जर बघितल्या तर तुम्हाला अर्थ मध्ये काय आहे? अर्थ इज नथिंग बट द बिग मॅग्नेट. Like this. This is the geomagnetic north direction, that is the pole. Here the geographic north pole. This diagram is given in your book, that is the 12.5. And now we are going to take just that means the definitions which is related to this earth magnetism. When we consider this earth is a magnetism, and these are the basic definition, that is this is the geographic south pole. This is the geographic south pole, that is the geometric, here the geographic and geomagnetic south pole, and this is the geographic north pole, and this is the geomagnetic north pole. That means that there is the slight distance change in there. See, this is the diagram which is not given in your book, but for your explanation I need this, so I have taken. The earth is considered to a huge magnetic dipole. Fictitious magnetic north pole of the earth is located below the Antarctica, while the south pole S is below the North Canada. काय आहे हे की जर तुम्ही अर्थला एक मोठा असा मॅग्नेटिक डायपोल जर समजलं तर तुम्हाला एक आभासी त्याचा मॅग्नेटिक नॉर्थ पोल जे आहे ते तुम्हाला कुठे मिळेल? बिलो द अंटार्क्टिका. आणि त्याचं साऊथ पोल जे आहे ते तुम्हाला कुठे मिळणार आहे? तर नॉर्थ कॅनडाला. द स्ट्रेट लाईन्स NS नॉर्थ साऊथ जॉईनिंग दिस टू पोल्स, यानी ह्या दोन्ही पोलला जी लाईन जोडते त्याला काय म्हणायचं? मॅग्नेटिक ऍक्सिस, which is denoted by the symbol MM dash in your textbook diagram, that is the 12.5. See, MM dash, and this is nothing but the what? This is nothing but what? That is the magnetic axis. And what is magnetic equator? A great circle in the plane perpendicular to the magnetic axis is magnetic equatorial circle, and which is given by AA dash. And it happens to pass through India near the Tiruvananthapuram. म्हणजे एक्झॅक्टली जर तुम्ही हे सगळं तुमच्या जिओग्राफी मध्ये बघितलं तर तुम्हाला हे सापडणार आहे की आपलं मॅग्नेटिक इक्वेटर कुठे आहे, मॅग्नेटिक ऍक्सिस कुठे आहे. ओके, then the next concept which is related to that is the definition. See, the geographic meridian. What is the geographic meridian? This geographic meridian, see here, this is the plane perpendicular to the surface of the earth, that is the vertical plane perpendicular to the geographic axis is geographic meridian. And then magnetic meridian, a plane perpendicular to the surface of the earth. This is magnetic meridian, perpendicular to the surface of the earth, perpendicular to the surface of the earth, vertical plane, and passing through the magnetic axis is called the magnetic meridian. ह्या डेफिनेशन तुम्हाला ऍज इट इज पाठ कराव्या लागणार आहेत. डायरेक्शन ऑफ द रिझल्टंट मॅग्नेटिक फील्ड ऑफ द अर्थ. Earth is always along or parallel to the magnetic meridian. See, this earth is always along or parallel to the magnetic meridian. Now the next definition, magnetic declination. What is this magnetic declination? Angle between the geographic and magnetic meridian at a place is called as the magnetic declination. That is the alpha. Those students who are going to study in geography, after this they can see this in their geography, these are the terms. The declination is a small in India. It is near about 0 degree 58 minutes. Okay, west at Mumbai, and 0 degree 41 minutes, that is angle, it is having the alpha angle, that is the east at Delhi. Thus, both these places, magnetic needle shows true north accurately. These are the definitions which is related to your now. See the last. This earth is a big magnet. The earth magnetic field is though to originate with moving charges. The core is probably composed of iron and nickel, which flows as the earth rotates, creating electrical currents, and that the result in the earth's magnetic field. Note that the magnetic North Pole and geographic North Pole are not in the same place. See, North geographic pole, and this one is the South geographic pole. These are not in the same place, and the magnetic North Pole acts as if South Pole of a huge bar magnet were inside the Earth. You know that it must be a magnetic South Pole, since the north end of a magnetic compass is attracted to it, and opposite, that means it opposite, just 1 minute, opposite, or it is at end of the magnetic compass, it is attracted to it, and opposite poles attract. Okay, these are some diagram which we have I have taken from net for your understanding, but in your book the refer, you have to refer the diagram number 12.5, and these are the definitions which is related to this. Okay, and important things of this chapter, that is these all definition which is related when we consider the earth magnetism. That means n pole and s pole. If it has a freedom to rotate, if any object on the earth, it show the north south pole. And the last thing, that is the what is this declination? In your book diagram number 12.7 and 12.6, what is this declination? Suppose this is the magnetic meridian here. The angle between the magnetic meridian and the geographic meridian at a place is declination. That is the declination at that place. It varies from place to place. The lines shown on the map through the places that have the some declination are called as the isogonic line. The line shown on the map through the places that have some declination, that is the isogonic. The line drawn through place that have zero declination is called as the agonic lines. Okay, or deep, or what is this inclination? That is the delta. Here this delta. The angle between the horizontal component of the Earth's magnetic field and the Earth's resultant magnetic field at a place is dip or inclination at that place. It is 0 at the equator and 90 at the pole. And lines drawn up on map through places that have the same dip are called as the isoclinic lines. I know student, you can't understand because these all concepts are related your geography concept. Okay, here only remember these things. That is the delta which we have taken, that is the year, that is the magnetic inclinations or angle of dip, that is phi, we must know. Then Earth's magnetic field. Okay, here see diagram number 12.6 and 12.7. Here the magnetic inclination or the angle of dip, that is the phi. It is nothing but the angle made by the direction of the resultant magnetic field with the horizontal at a place is inclination or the angle of dip at that place. Here the, see this is the compass needle, this is the horizontal, this is the dip or the angle of dip, that is the Earth's magnetic field B bar. See, angle made by the direction of resultant magnetic field. See, this is the magnetic field B bar. Here and with horizontal, and this angle, with the help of this diagram you can easily understand what is this magnetic declination or dip angle. The angle between this horizontal and the magnetic field is called as the dip or the angle of dip. Now the next concept, Earth's magnetic field. Magnetic force experienced per unit pole strength is magnetic field. That it can be resolved components along the horizontal BH and along vertical. That is the P bar V. Vertical B bar V, horizontal B bar H. H for horizontal and VV for the vertical. The vertical component can be conveniently determined. That is the BH is equal to B cos phi, and this BV vertical component that is related to sine. That is the B sine phi. Therefore, BV divided by BH is nothing but the tan alpha. These are, we have taken the reference of the diagram number 12.6. Okay. Therefore, this B square is equal to BV square plus BH square. Therefore, this B is equal to under root BV square plus BH square. That is the Earth's magnetic field, B bar. Here at the magnetic north pole, what happened? This B bar becomes BV. Why? Directed upward direction, and at that time your vertical magnetic field it's become 0 or it's become 90. So 90 it's become B bar is equal to BV bar. Here we are just putting the value of 5. That is the in special cases. And then at the magnetic south pole, what happened? This B bar is equal to BV, that is the directed downward. That is the B bar H is equal to 0. Just 1 minute. Okay. Here, the magnetic maps of Earth. Here, at the magnetic north pole, what happened? This B bar become B bar V. That means only vertical. Why? Because this horizontal becomes 0. At the magnetic south pole, what happened? It's become vertical. Again, why? This become 0 or 270 degree. Anywhere on the magnetic great circle, magnetic equator B is equal to BH along the south to north. This BV becomes 0, and at that time this phi is also 0. So magnetic map of the earth, magnetic elements of the earth, that is BH, alpha and dip angle phi, vary from place to place and also with time. The map providing these values at different locations are called as the magnetic maps, and these are extremely useful for navigation. Magnetic maps drawn by joining places with the same value of a particular elements are called as the isomagnetic charts. And the lines joining the place to place of equal horizontal components are known as the isodynamics isodynamic lines. And again, line joining the place of equal declination alpha are called as the isogonic lines. And last one, that is the lines joining the place of equal inclination of dip, that is the phi, are called as the aclinic lines. In this way, here this total chapter we have completed today, and these are the some examples related to these formulas. Okay, this whole chapter is very theoretical, so you have to thoroughly read it, student, and then you can understand this chapter. Okay, if any problem when we meet offline, at that time you ask me. Up to this, you read this chapter carefully. Okay, student, today we stop here.